Hello, mathematicians. We're going to do a little bit of math together, and I'm going to show you the pages that I have and where I got them, and then we're going to work through some problems together. And I'm going to talk just a little bit about the problems because what's important today is not the problems themselves. They're pretty simple to solve. So it's not at all about solving the problems. I want us to just remember that from the very beginning. It is about writing equations that match up with the story and the information that we have. Okay, so here I am on today, Wednesday, 5/13, and I opened up this home connections page by going like that, and I have it open right here. So it looks like this, and it's got some ants at the top. And then I went to this tool right here. It says number frames to model with. And I opened up these number frames that some of you have opened up yesterday. And it looks like this. So we're going to use this to build the story to help us write an equation that matches up with the story. Okay, so we're only going to take information that we have in the story problem to write our equations. Let's just start off with the first one. So I'm going to read this to you. It says facts and questions. A story problem gives you some facts and asks a question. For each problem on this page, underline the facts. I can't put a line under it, but I'm just going to kind of point it out to you guys because I haven't figured out how to use the writing tool on here. You could do it on your page though. Put a box around the question, solve the problem, and show your work. Write the answer on the line. So it says, here's the example. There were 10 army ants, okay? Here's where it has the 10. 3 went out to get some food. How many ants were left? Now there's a box around the how many ants were left. So in our equations, we're going to put a box where the question is, or what's unknown. What is the part of this that we don't know until we quickly compute it or calculate it in our minds? So what was the part that we don't know from what's underlined? There were 10 army ants. Well, we know the 10 to start off. 3 went out to get some food. So we know that going out to get something is going to be subtraction. It's going to be something that's taken away. So we knew 10 minus 3. How many ants were left? So the story does not tell us that there were 7. Even though we could probably quickly solve that because we know that the parts of 10 are 3 and a 7, but just keeping in mind that this is not about solving the problems today. Okay, so 10 minus 3 equals 7. I'm going to show you how I would do this on these number frames. First of all, I'm going to open up this little picture box. And right now, my red counters are circles and my blue counters are circles. I don't have any ants, but I do have bugs, so I'm going to change those to ladybugs. And then I'm going to change the blue ones to ladybugs too. Okay, so we're going to close that. Now, I'm going to look at these. And for this problem, I only started off with 10. So I really only need a 10 frame to be able to make a model of this. I'm going to open up my 10 frame. And I'm going to look at the problem one more time. It said there were 10 army ants. Okay. 10 army ants. They're all kind of blue, which means if I touch them, all of them would move over at the same time. So I don't want that. So I'm going to just click over there and it takes the blue away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me pick up a marker and write my equation to go with this. I'm going to use red for, whoopsie. See how it was crooked? It has to be straight up and down to show me that I'm holding it. There were 10 army ants. 3 left to get some food. How many were left? This is where the question is. This is what it's asking us to solve. Okay? I'm going to put my pen down. See how it went sideways? And I'm just going to act it out and take the 3 away that left. And I know that there are a 4 and a 3, or double 3s is 6 and one more is 7. So I know And from the example, I know that there were 7. So I'm going to put it in the question box, the box that means sum. Okay, so I'm going to see that, the little swirlies. That means I can just erase everything on my screen. I still have these guys as bugs. Let's read the next one together. We're going to do these 3 problems. 6 ants are working hard. Some more come to help. Now there are 13 ants. How many ants came to help? So let's see. There are 6 ants working hard. Some more are going to come help. And now there will be 13. So I'm going to need space for at least 13 ants. So the 10 frame isn't going to work. So I'm going to choose the 20 frame. And keep track of what we know. Pick up a pen. 6, whoops, whenever it does that, it means I don't have it in my hand. 6 ants are working hard. Some more came. If they came, they were added on. Some more came. Don't know how many came yet, even though you might know it in your mind. Then there were 13. Okay, so let's see. I'm going to put my pen down, and I'm going to start off with 6 ants. So I have a 1, a 5, and a 10. 10 would be too many, so I'm going to put 5 and 1 more. So here are my 6, and I need to add more until I have 13 altogether. So I'm going to switch colors. Let's see. If I put, whoops, put that guy back. Didn't mean to take him, so he can just go to the side. Or actually, I can delete him by clicking on him and hitting the trash button. Whoop, he doesn't want to go away. Okay. All right, now I put 5 more. 6 and a 5, is that going to get me to 13? It's not, because 2 5s is 10. 1 more than that is only 11. I'm going to need that. That would be 2 6s, so that's 12. So we know that double 6s plus 1 more would be 13. So that's 6, 7. Okay, so we are going to solve it, but it's more about thinking about what was unknown. So this is called the change is unknown. We knew we started with 6. We knew we ended with 13. But we had to solve what was the change that happened. 7 more came. Okay, now clear that guy. Let's read this one. There are 7 ants at the top of the tunnel. There are 4 ants in the middle chamber. There are 5 ants in the lower chamber. How many ants in all? All right, we're going to need, let's just use the 100 so that we know we have enough space for all these ants. Let's read it again. There were 7 ants at the top of the tunnel. There were 4 ants in the middle chamber. There were 5 ants in the lower chamber. Okay, so we know that there were 7 in the top of the tunnel. There were, I need to check it again. Let's see. There were 7 ants at the top. Oop, there were 4 in the middle chamber. So see how I can click so that only one of these is blue? I'm going to take it away and just put it off to the side. 7 ants at the top, 4 in the middle, and 5 in the lower chamber. I'm just going to switch colors now. So here I know how many there are. I know the changes, but I don't know the end. So I am going to go like this. 7 plus, I'm going to change my color just to match up with those ants that are in the middle. Plus 4 plus, let's see, plus 5 more equals how many in all? Let's ask us how many were there in all. I'm going to put my pen down and I'm going to move these guys around a little bit. So what I can see is that I have 1, 2, 3, 4, 5, 6, 7. I'm actually going to split up this 4 because I know that if I put 3 of them here with the 7, that a 3 and a 7 is going to be a 10. And then I can change that 5 to a 6. Look at that. I changed 7 plus 4 plus 5, changed it into 10 plus 6. 10 and a 6 is a lot quicker for me to solve because I know that a 10 and a 6 is 16. Okay, so this was our equation. We had 3 add-ins. We had to add 7 plus 4 more, plus 5 more for that. We're going to clear that guy. And we're going to look at this one. There are 6 ants. Ooh, each ant has 3 seeds. Let's see about this one. 6 ants. Each ant has 3 seeds. I'm going to change these to seeds. I am going to do this. Each ant has 3 seeds. So I could do this. That's for one of the ants. Oops. Oh, see how they get on top of each other? So I need to make one of these for each. It went right on top, so I have to drag it down. I have to make one of these for each of the ants. Each ant is going to have 3 seeds, and there are 6 of the ants. Okay, 6 ants. This could be 1 for one ant, for the second ant, for the third ant, for the fourth ant, for the fifth ant, for the sixth ant. Okay, and each one needs to have 3 seeds. Oops. What is my equation going to look like for this? What do I know? Am I going to say 6 plus 3? That doesn't really make sense because I'm not adding the ants to the seeds. I have to add up all the seeds. The question is not asking how many ants there are. It's saying how many seeds are there all together if there are 6 different ants and they each have 3 seeds. So 3 seeds for each ant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I just had to add up 3 6 times. 3 plus 3 plus 3. It's taken me a long time. Plus 3. How many 3s do I have? 1, 2, 3, 4. Plus 3. Plus 3. Let's see. 1, 2, 3, 4, 5, 6. Equals all the seeds together. Now we skip counted by threes. We could skip count by threes. 3, 6, 9, 12, 15, 18. We also counted them by ones when I first did it. Now that took a long time to write all those threes together, so I'm going to show you a shortcut. 3 seeds taken 6 times. Taken 6 times. Okay, was equal to 18. Whenever we add a number over and over, we take groups of that number. We had 6 groups of 3. We could use multiplication symbols. So we'll start to talk about that soon. But I'm sure you could do all of this on your own, and I want you to get out the Number Frames app and explore along with this page.